Hi everyone, here comes a very quick screencast of what we covered in class today on the unit circle. So I'm just going to use my little GeoGebra file here that I've prepared. You can see we have a circle here with a radius of 1. I have a blue spot that touches the circumference, and as I change the angle theta here, I'm measuring the angle down in the corner here from the x-axis moving around in an anti-clockwise direction, and then the radius shoots across to the circle. The blue dot is on the circumference, and these are the coordinates of the point. So the x-coordinate is first. X-coordinate is horizontal distance from the origin, could be measured at the bottom, same measurement would be across the top. And the second, the y-coordinate, is vertical measurement from the origin, could also be measured over here. Now, what I've got right there looks like a right triangle. It is a right triangle. And if I wanted, for instance, to know the sine of angle 60 degrees, I would use the opposite side, divided, which is the y-coordinate, divided by the hypotenuse, which is 1. That's why I've written sine of the angle equals y-coordinate. Dividing by 1 doesn't matter. It doesn't change it. If I wanted the cosine of the angle, I would go the horizontal coordinate, the x-coordinate, the adjacent side, divided by 1. Again, dividing by 1 doesn't matter. And so we can see the x-coordinate of this point is decimal 5. The cosine of 60 degrees is 0.5. The y-coordinate is 0.87. So the sine of 60 degrees is 0.87. Now I can increase the angle a bit. You see the angle is larger, the y-coordinate is larger, the x-coordinate is smaller. As the point moves towards the top of the circle, it's getting higher, but it's getting closer to the origin. So let's keep an eye on what's going on here. I'm going to record, don't worry about tan just at the minute, we'll worry about tan afterwards, but I'm just going to record sine and cosine. So at 0 degrees, I can see the sine is the y-coordinate, that's a 0. The cosine is the x-coordinate, that's a 1. Now I'll move by 30 degrees, and I have now a y-coordinate, the sine 0.5, and the x-coordinate 0.87. Now I'm going to let you pause the video for a minute and then fill in the rest of the spreadsheet table for yourself. This GeoGebra file is available on our class page. So go and grab a copy of it and run that in GeoGebra. If you're not in my class, there's plenty of things like that out there on the GeoGebra Resources tab. So go off and finish that table now, and I'll be back in a moment. Okay, hopefully you finished the table for yourself, and I'm just going to go down here and grab my copy of what should be in the table and bring that back up to here. Yes, I want to replace what was already there, and there it is. Now I could graph those if I select all 3 of those columns and insert a scatter chart. Let's have a scatter chart here with dots for markers and lovely smooth lines. That's a sine and a cosine graph. Isn't that wonderful? Now I'm not actually going to do that one because you probably noticed once we got all the way around, once you went all the way around to 360, then that's exactly where we started from. Now that's where my slider finishes. But imagine I could move that forwards again to 390 degrees. Then I'm just going to be the same as if it was back at 30 degrees. So I've created a second cycle of data here. The second cycle of data goes in for sine and for cosine, and I've already graphed these. I've got them over here. Oh, something went weird then. What happened to my graph? My graph is broken. I think I messed up my graph. Let's refresh. Oh, the graph is definitely upset. See what I can do. Ooh, something very weird's happened. Don't know what's going on with that. So I'll need to. I think I'll need to just reset the graph. But that's okay. You get the idea. we're graphing the sine and the cosine function across 2 cycles. That's what we did in class this afternoon. Thanks for watching, and I'll see you tomorrow.